Hey, yo, you ready? Let's do it. I'm the definition of half man, half drugs, ass to clubs, bad boy, that's what's up. After bucks, crush crews after us. No games, we ain't laughing much. Nothing but big things. Check the hit list, how we twist shit. What changed with the name? We still here, you're rocking with the best. Don't worry if I write rhymes, I write checks. Who's the boss? Dudes is lost. Don't think cause I'm iced out, I'ma cool off. Who else but me? And if you don't feel me, that means you can't touch me. It's ugly, trust me. Get it right, dog, we ain't never left. We just move in silence and rep to the death. It's official, I survived what I've been through. Y'all got drama, the saga continues. We ain't going nowhere. We ain't going nowhere. We can't be stopped now, cause it's bad boy for life. We ain't going nowhere. We ain't going nowhere. We can't be stopped now, cause it's bad boy for life.
All right, y'all. Welcome to Mr. Marini's class. It is September 22nd or September 23rd. Depends when you're watching this. Let's talk climate today, kids. You did a little warm up when we talked about climate change. And now we're going to talk about climate in general. Climate's huge. Climate's just a huge thing in geography. Obviously, where you live, the climate depends on where you live, and how the climate is can affect your life greatly. So let's get going. First things first. You should have gotten that note catcher from Mr. Marini. So open the note catcher. Right? Do like I have done. I'm going to do, if you haven't done it already, you're going to make a copy. I'm going to call mine Marini Climate Notes Catcher. I'm going to save it in my geography file. All right. There we go. So this is what you're returning in today. No Pear Deck, no Ed Puzzle. You're just going to return in this Google Doc. We're going to do this every once in a while when you need notes, like actual notes, not just looking at a presentation. And with climate, you guys are going to need a lot of notes and a lot of practice. So that's why we're doing this. Okay. So let's get going with our presentation. And I'll jump back and forth to help you guys a little bit. So the big thing, when we think climate, we've got to think about the conditions, right? What's it like outside? But then there's this other word that we use called weather. And those kind of get confusing, because when people say climate change sometimes, they'll be like, oh, well, it's snowing outside. Well, that could be the weather today, but climate, right, is a little bit different than weather. Weather, if you can see right here, y'all, is short-term description. Today, what is the weather? You would say, what is the weather today? Climate, on the other hand, is a description of the precipitation and moisture and conditions of a location, right, over a long period of time. So you wouldn't say, what's the climate today? Because that's not accurate. You would say, what's the weather today? What is the climate for the year? Okay? What's the climate in Brazil? Because climate is more of like the average weather. If we took all the weather up for the year, what would be the most likely weather we are going to have based on where we are? Okay? Brazil has a climate. Now, it could get cold in Brazil, it could get hot in Brazil, but generally, it's got some rules to it, and that's what climate is. Another slide for you, right? Weather can change within minutes or hours, right? Climate, on the other hand, again, is temperature, right, over sort of the whole year. If you go to wherever this is in July, probably it's going to be up around this temperature. It could drop, but it's probably not going to drop down below 20 because that's not the climate. Okay? So climate average, weather one day. Okay, let's talk about some things that affect the climate. First off, seasons, right? Your seasons are going to change your climate. If you've ever seen the Earth, you know it actually doesn't rotate straight up and down. It rotates kind of at an angle, like this picture is showing you. And the sun is facing us, right? So depending on when we rotate around the Earth, which way the tilt is, in June, right, we're like kind of right here on the Earth. That sun's really close to us and giving us direct sunlight. In December, you can see, well, now we're a little bit further away, right? We're actually up here, okay? And now we're not getting that direct sunlight and we're actually further from the sun, okay? So that's the big thing, obviously, that's going to change climate, and that's for everybody. I mean, the equator is going to change a little bit, you can see. Even though it's in the middle, it's going to experience some change, right? Equator gets the most sun, but it's going to get some change as well. And you can see, kind of reflected in world temperatures. These zones, the green zones right here, are like where we're at. We're in the summer, right? It'll warm up, but here's the winter now. Here's winter in Colorado. Now it's getting blue. Now it goes back to green. Now the opposite down here, Argentina. It's blue in the winter. In their winter, which is our summer, gets green, orange in their summer. Down the middle here, it's pretty much orange to red, but pretty much stays consistent because it's the equator. The tops never get too close to the sun, so they stay blue, maybe a little bit of green. Antarctica, really cold because it's basically a giant ice chunk, a continent, gets really cold and stays really cold all year long. Okay? Currents, another thing we need to talk about. So how does weather move? Why is the weather changing? Well, because of the winds. And then we have certain winds that are pretty predominant. In other words, they happen throughout the year. Okay. And this is one of these would be called the Gulf Stream. That's what affects us a little bit. Okay. You've got the Brazil current. These are warm and cold weather currents, wind currents, right? Blowing constant wind that moves weather kind of in the same, moves weather around the earth as things heat up and things cool down. Right? Let's pause for a second. Let's go back to our notes catcher. Okay. Let's go back to weather. Let's define this. Okay. Weather is the conditions of one day in the atmosphere. Can change. Oops. Change minute to minute. Obviously, if I write this down and you're trying to watch the screen, pause it, go to your note catcher, unpause it, come back and forth. Okay. Climate, right, is the average conditions in a location over the period of a year. Okay. Seasons, we said, right? The tilt of the earth changes how much direct sun certain places getting. How about temperatures, right? Temperatures tend to be warmer towards the equator and colder towards the poles. Lastly, currents, right? Currents are consistent wind patterns that move weather around the earth. Okay. I'm gonna let you do precipitation by yourself when I come back then. But again, pause, look at this. I'm gonna go ahead and get going so this video doesn't take 3 years. Last thing, and you're gonna do this one. You need to pause and write what you learn about this one yourself. Precipitation, right? I think we've all been in rain, and we've all been when it's really dry. We know that precipitation greatly changes, how the conditions feel. They can also affect temperature. Colorado is really dry, so at night our temperature drops a lot. If you've ever been to a more humid place where there's lots of precipitation, like down here, especially in Central America or South America, it doesn't get very cold at night because the moisture kind of holds on to that temperature, right? In the desert, right, especially the Sahara Desert right here in Africa, temperatures can swing crazy, like 60 to 80 degrees a day, And we even had that right a couple weeks ago when we swung from really hot 90 degrees to really cold. Now, that wasn't all because of precipitation, but partially because some moisture rolled in. Right? So, precipitation is any sort of rain, snow, sleet, and hail. It has a big effect on the Earth's temperature, but also obviously just in general on the climate. What happens to the land, right? If you have more moisture in the land, you can do different things with the land. If the land is drier, it's tougher to live off of generally. Okay? So go ahead and pause this, go back to the notes catcher, and write down what you learned about precipitation. Cool. Okay. So there's 3 types of climates we basically need to know. We kind of saw this in that temperature map, right? There's tropical zones, which we're going to look at in a second. Temperate zones or moderate zones sometimes. This is called moderate zones or temperate zones. And polar zones. Polar zones, right, are these zones up here. Usually we're getting to like the 50s and 60s north and south latitudes. We're getting really high and really low on the map here. All right? When you think of polar, right? Located in Arctic and Antarctic, climate's extremely cold most of the year, very short summers, and cold, dark winters. You know, Antarctica and the poles get to the point where there's barely any sunshine. Basically, it's like 24 hours of night for a couple months out of the year. Okay. Temperate zones between the polar and the tropical. This would be most of where we live. Lots of Europe and China, right? Argentina and Chile, we tend to think of them as tropical. They're not. They're very moderate zones. They're very temperate zones. Right? Mild temperatures for the most part. Never too cold or never too hot. And I know we think it gets cold and hot sometimes here, but like 120 degrees, that's really hot. We get to 100, and that's pretty hot for us. You know, we get below 0 a couple times. Well, there's up in Antarctica, you're below 30 much of the year. Right? It's going to be changing season. That's a big part of the temperate zones, right? Big time season change. Tropicals don't have season change as much. Polar barely has any season change other than light. The moderate zones are going to have colder winters, warmer summers, mild spring and falls. Lastly, your tropic zone between the Tropic of Cancer, the 23-27 line, and the Tropic of Capricorn, the 23-27 south line. Warmest average temperatures and get the most rain, hot and moist. Okay? You think of Hawaii, you think of rainforest, I always think of Costa Rica, places I visited that are tropical. It's hot and muggy all year round. It gets wetter, but it never gets too cold. Okay? So, how we look at climate geography, we're going to use something called a climograph. Right? A climograph looks at the 2 things we've just been talking about. How wet is it, and how much, and what is the temperature? And it pairs them off next to each other, so it gives us a good idea, a good visual of what a climate looks like in a place. Okay, I'll show you what a climograph looks like. Here's a blank climograph. I'll show you some in a second. What you're going to do when you make a climograph is you're going to show the precipitation, in other words, inches of rain or snow that fell in this area every month by month, and you're going to do the average temperature month by month. We're going to do a bar graph for the temperature and a line graph for the precipitation. No, sorry, we're going to do a line graph, that's wrong. A line graph for the temperature, a bar graph for the precipitation. And here's a couple examples. Okay. Right now, you're probably looking at this and it looks like a couple of graphs that don't mean much. By the time we're done with geography, you'll look at this and be like, oh, I know what's going on. So, the temperature is a line graph, like we said. You get the average temperature each month. This is Fargo, North Dakota. You can see Fargo gets really cold in January. Never gets ridiculously hot, but it gets pretty warm in the summer. But look at the moisture, right? Big time switch, big time swing. Jump across the world, over here to Paris, France. Less of a temperature swing, pretty moist year round. Now, go ahead and go to the notes catcher and write down some differences you see between these 2. Oh, shoot. Oh, wait, my fault. We're going to go back for a second. I totally spaced this. Pause for a second before we get to climb graphs. What I want you to do is go to the zones You're gonna do this really quick in your notes catcher. Go to the zones and go to Google image search and find a picture that fits the polar zone, the temperate zone, and the tropical zone. Right? When you're done with that, come back and then we'll compare Fargo to Paris. Right? Pause the video, go find 3 pictures. One you can copy and paste in the polar zone, one in the temperate zone, and one in the tropical zone. Any picture that reminds you of those 3 zones. Okay, hopefully you did that. So now, tell me about Fargo and Paris. I'm going to put that back up there. On your notes catcher, tell me something about Fargo. Tell me one thing about Fargo. Tell me one thing about Paris that's different between the two. So if Fargo has this, what does Paris have? Pause the video and go ahead and do that. Okay, cool. Just to give an idea of what, if we're looking at a climograph, these are some examples of things that we will know by looking at a climograph. We look at Algeria here. We see super hot temperatures, very little precipitation, very little rain. It's pretty much Algeria is a desert. A rainforest, we can talk about, it's going to be really hot and humid. Look, it's hot year-round. Look at the moisture. It drops a little bit, but it's pretty wet year-round. Remember, the blue bar graphs are the moisture. If you go to Peoria, Illinois, go to Illinois, right? Illinois, never been to Illinois, kind of looks like eastern Colorado a little bit. Pretty mild, pretty grassy. Not that much moisture, some, but temperatures that change a lot. Grasslands usually fall in that temperate zone because they have the big temperature switch between the seasons. Alaska, freezing, right? Sort of like a frozen desert. Very little moisture. Cold, cold, cold gets maybe up to we're talking 5 degrees centigrade, so maybe now we're getting up towards 50 degrees in the summer, and then drops to negative 25 by the time we get to December. Right? So this is just an example of how you can just look at a climograph and tell what that place is going to look like, even though you don't have a picture. Let's look at Boulder, Colorado. All right, let's look at Boulder. Okay. You can see big temperature change. In the winters, it's around 30 degrees Fahrenheit. In the summers, it's close to 80. That big temperature change like we experience in Denver. Quite a bit of moisture, then gets pretty dry come December. May and April, spring, very wet in Colorado, and it kind of dries out a little bit and gets a little drier in the winter. All right. Our winters are cold here, pretty cold, but they're not actually as wet as like Minnesota and Iowa. So what I want you to do now is go to your notes catcher. All right. Tell me what the high temperature is in Boulder. We're going to do this one together. The high temperature is roughly, we're going to say, probably 70. Average high temperature is 75 degrees. The low temperature is, it looks like it drops to about 32 degrees. This is Fahrenheit. But we're going to put an F by it so we know it's Fahrenheit, because these climographs switch between Celsius and Fahrenheit. And those are just two different ways of looking at it. It's okay to use both. We use both a lot in America. Rainfall. We're just going to write something real quick. We'll write wet springs. Wet spring. Oops, that's wrong. Wet spring. Dry. Oops, zone. So dry winter zone. Definitely in the temperate zone. Observations. Pretty mild all year round. Cool. All right, next up, let's do, so next up, you're going to do these by yourself. Now, you're going to do the next 4 by yourself. You're going to do the same thing I just did. All right, I'll kind of talk you through it, then pause the video while you're looking at this. I'll make it big for you. Okay? So now, look at Antarctica. Here's your high temperature, right here. So when we're looking at temperatures, use the right side here. When we look at precipitation, we're in millimeters and centigrade now. Look how little moisture there is in Antarctica. Big frozen desert. So Go to your notes catcher now. Pause the video, go to your notes catcher now, and look at that. Sorry, fill out the Antarctica part of the notes catcher. Next up, Uganda. Right? Uganda, okay, look now, pay close attention to temperatures here. They messed with the scale really quick. This is a 1 degree scale. 23 to 24 degrees centigrade is really hot. So look how hot it is most of the year in Uganda, and look how wet it is. So looking at that, write down, pause the video, go to your notes catcher, write down the high temperature, it's right there, right here, write down the low temperature, right there, and then describe how much moisture there is in Uganda, how much precipitation, how much rainfall. And then tell me what zone you think it is. All right, now we're going to do Haiti. I'm not going to say anything about this one. You're going to do these last two basically on your own. Go to Haiti, pause the video, go fill out that information about Haiti. Okay, last one, you got Greece here. Look at Greece. Go fill out the information in Greece. Remember, the red line graph, or sometimes a dot graph you call it, where you connect lines, but the red line graph is temperature. The blue bar graph is rainfall, precipitation, snow and rainfall. Go ahead and go pause the video and go do that one. Okay, so now we're to our exit ticket. I need minimum 3 sentences here, children. Exit ticket. What is a climate graph? Explain in your words what a climate graph shows us, how do we read it, and why do we use them? What can it tell us about the climate, and why is it so useful? I would definitely go back to this is a great graph, this is a great page to look at, okay? This is a good page to look at. I mean, any of these climate graphs, think about what we learned from looking at that, and then go ahead and write 3 sentences, your exit ticket.